So this is something new for us in Year 9, and we're looking at equations with variables on both sides. Everything up to this point has always had the variable, whether it's x or m or q, on one side of the equation, either the left or the right hand side. This time, sometimes we have variables on both sides. So our learning goal hasn't really changed, we're just looking at a different type of that problem. So the easiest way to think about it is that we always try and group our variables on one side, or our pronumerals on one side, and constants on the other. Makes the equations easier to solve. So the starting point is different, but after that first step, everything is the same. So we still use our inverse operations, and we still need to remember the sign in front of the constant or coefficient is the operation to reverse. As a rule of thumb, we try to group our pronumerals on the side with the greater pronumerals. It just means we don't have to deal with negatives, which actually means one less step we've got to deal with, and also reduces some of the complexity we have to deal with. So here's some examples we're going to look at. Here's our first one. So we've got y's on both sides of the equation. What we want to do is move these y's across to the right. Now, if we remember that this is actually plus 3y, the inverse of that is to take 3y from both sides. Now, the reason we want to take this across to this side is because we have more y's on this side. It means our numbers will be positive. So we do that, 5y take 3y equals 3. We have 2y equals 3. So now it's a simple equation that we can solve. It's a single step from here. So we undo the 2 by dividing both sides by 2. So y equals 3 divided by 2, which equals 1.5. To check your answer, look at both sides separately. So left hand side equals 5 times 1.5, which equals 7.5. The right hand side equals 3 times 1.5 plus 3. So that's 4.5 plus 3, which equals 7.5. And because the left hand side and the right hand side are the same, our answer must be correct. Second example. This time we've got much larger x's on both sides, or groups of x. And we've also got constants on both sides. The rule of thumb is, wherever you have a negative, make it positive by adding it to the other side. So the easiest thing to do in this case is move this 4x across to the left hand side. So we do that by adding. Let's take 4x here, so we'll add it to the other side to make it 4x plus 4x. Because we took the x's to the left, we'll take the constant to the right. So instead of plus 5, we'll minus 5 on the right. So we end up with a group here of 11 x's, and on the right, negative 3. Get x by itself, divide by 11. Once again, we can check our answer by substituting to the left and the right. If the two sides equal, we're correct. And this one here uses the knowledge from our last lesson where we need to expand first. So we use that distributive law to multiply out the 3 to both terms. So we have 3x plus 3 on the left. Once again, we've got to take 2x. We're going to take that across to the right, move the constant to the left. So we end up with 3x plus 2x, the opposite of taking 2x. On the right, 14 minus 3 as we move it across to the other side. Group our like terms, you get 5x equals 11. If you get x by itself, you divide the 11 by 5, which equals 2.2. So either of those answers there are correct. Once again, substitute into both sides to see if our answer matches. This is no different to the previous example, except we have to expand both sides. So we multiply through the 2 on the left, and multiply through the 4 on the right. So on the left, 2x is 2x, 2 times 3 is 6, 4 times x is 4x, 4 times 7 is 28. Once again, group our like terms. This time we're going to go to the right because we've got more x's on the right. It means that 28 will come to the left. So 4x, take 2x, because remember that means plus 2x. And on the left here, we've got our 6, and the opposite of plusing 28 is taking 28. So negative 22 equals 2x. Opposite of timesing by 2 is dividing by 2. So negative 22 over 2 equals negative 11. Once again, substitute both sides should equal. So this is equations on both variables on both sides. It really isn't more than one extra step than what we've done before.